Hello and welcome everyone, and thanks for joining us today for a new episode of Let's Talk About Data Show. My name is Ibrahim Umar. I'm a database specialist solutions architect. I'm based out of London, and today we have an interesting topic to cover where we are going to talk about evolving with DynamoDB's with new announcements. So last year we covered the new announcements for DynamoDB with the same host, the guests that we have here, Aman and Lee. And again, this time we have them in order to talk about the new announcements that have been announced recently. Aman, would you like to start and to introduce yourself, please?
Sure. Thanks for having me. Hi, folks. My name is Aman. I'm a DynamoDB solutions architect here at AWS. I'm based out of Dublin, Ireland. So those of you watching from EMEA, from Americas, from Asia, hello to everyone. And yeah, I have with me Lee.
Yeah, thanks, man. My name is Lee Hannigan. I am also a DynamoDB solutions architect, and I am also based in Ireland. Really happy to join today, Abraham. Thanks for having us.
Thanks, guys. Thank you so much. And thanks a lot. We have also Tony supporting us on chat today. And for our audience of viewers, please let us know where you are tuning from, and let us know if you are already using DynamoDB. If have you ever heard about it? What's your impression about it? Let us know. And yeah, without any further ado, let's start today. So the first thing that we want to cover today, or the first announcement that I believe it's an interesting one for almost everyone, which is related to the cost, the price reduction. Uh, I know that I've been here with AWS for almost 7 years now, and from time to time, we do this, we reduce the cost of the services so that it will be more convenient for our customers. So, Aman, would you like to talk a bit about that new cost reduction that took place?
Yeah, absolutely. So I think it's great where every time AWS has the opportunity, it can pass off. It can make use of the economies of scale and pass off savings back to the customer. And this time it's DynamoDB. I think AWS has a decent history on doing price reductions. As things evolve, things might be more efficient. Things might get more efficient. You might need more servers or fewer servers to do more work.
Mhm.
And so that's how it happens, how these price reductions come into play. So for DynamoDB, the most recent price cuts, and we can probably pop our screen up,
Sure.
were
Yes.
on.
Sorry, Aman, before going there. So we have Taylor. So tuning in from Otta using DynamoDB minimally, but want to learn more. So I can recommend where it will work for us. That's perfect. And then, hello, I'm working in testing. Can I switch to AWS? Host can switch to AWS, of course. And also, we have Sergey, best NoSQL database that I've been working with. That's great. Sorry, back again to you, Aman.
Yeah, no, that was important. Important updates to share. Good to learn about feedback directly from customers. So this price reduction was announced maybe last October or November. October it was. And we can probably pop in the link in the chat as well for the announcement. Basically, whoever DynamoDB supports two capacity modes. One is provision capacity, where users can specify how many reads and writes they want and just start off using DynamoDB with those reads and writes every second. The other capacity mode is on-demand mode, where you do not have to tell DynamoDB how many reads and writes you want. You can create a table, start off using it as you go, and you also pay as you go essentially. So you can be really spiky, you can be unpredictable, you can go to thousands of requests per second and then have no usage for the next few seconds, and you only pay for the request, which is in on-demand mode. So for on-demand throughput, we definitely want to encourage more and more customers to move to on-demand because it's just beneficial. Like there's no minimal operational overhead. With provision mode, you still look at auto scaling configurations. You need to manage some things here and there. Although DynamoDB is completely serverless, there are still some things to look and review. Um, with on-demand, there's no operational overhead.
Gives you more flexibility for it.
Exactly. So it's flexibility max, and the reduction in price makes it even more appealing now, with
Definitely.
50% price reductions on on-demand throughput, so reads and writes that you make on on-demand mode. And if you're using global tables, which is the multi-region deployment of DynamoDB, here you can have up to 67% of price reductions now with this announcement. So this went live 1st of November, and straight away customers saw benefit, experienced it, and we got some healthy feedback as well. So if you're able to see this screen, this was monthly cost for one of the customers for DynamoDB, and they're using on-demand capacity mode. So if you're already using on-demand capacity mode, overnight your charges were slashed by 50% in terms of throughput. So you didn't have to migrate to a different version or change some configurations. It just happened. You're still running the same application. You're still serving the same customers in without any interruptions. That's one of the features as well of DynamoDB, where you don't have the concept of database version upgrades.
Yeah.
You're always on the latest and greatest version, as we say it. And you can see that for on-demand throughput, the monthly cost of the table or overall usage for this one customer went down by more than 50%. Just in November comparing with October. So the 50% rate cuts or price reductions really helped this customer overnight without them spending any minutes of engineering hours making database version upgrades or changing things in their application.
Okay, that's really interesting. Just before going further, there's a question from Alex. It's asking about, is there a Docker DynamoDB version for local dev?
Yeah, there is. Yeah, you can use a Docker image for DynamoDB local for dev testing. Yeah.
Oh, really? I didn't know that. I thought that's only cloud native. You cannot have a local.
Yeah, you can have a local version of DynamoDB for sure. You can get it in Docker, you can get it in Maven, or you can download a jar directly on the AWS developer website.
That's nice. Another question also from Jenny. Uncertain if this has been addressed. Can we use auto scaling with provision capacity to optimize cost over on demand?
Good question. Do you want to take it, Aman?
Yeah, cool. So with provision mode, you do have this notion of telling DynamoDB how many reads and writes you want. I'm just giving some more context to that question, and it's a great question. Thank you. With provision mode, you have to specify how many reads and writes you want. Right. So definitely, auto scaling takes care of the scaling up and scaling down. And how auto scaling works for provision mode is it keeps track of your previous usage, more recent usage. So it decides, it asks you for a configuration of threshold to say 70%, right? So if consumed versus provisioned threshold is more than 70%, then it does a scale down, which means it will lower capacity because your buffer capacity is a lot, right? You have a 30% buffer, which is 70% threshold. Does that make sense? If your traffic is increasing on the table, your threshold is less than 30%, right? So auto scaling can then kick in. DynamoDB will scale up the capacity of your table accommodate that additional request load. So based on your traffic patterns, auto scaling will bring the capacity down and scale it back up. But the point here is that it is more of a reactive measure. It will see your capacity consumption and then react to it. It also sometimes it can take a while to react to capacity, right? So it takes about uh, in practicality, it can take about 3 to 4 minutes for auto scaling to kick in and then scale up the table. And while scaling down, it takes about 15 minutes of consume versus provision ratio and decides whether to scale down or not. So
which is not the case for the on-demand, of course.
Exactly. So with on-demand, you can scale up to tens of thousands of requests and then go back to zero the next second without any issues, and you only pay for the requests that you've made. So with provision mode, you're charged for the capacity you provision, whether you use it or not.
I see.
So although auto scaling can help you in a lot of ways with provision mode, if your usage is spiky, bursty, unpredictable, in those cases capacity planning can become very difficult. And so we recommend that you go for on-demand mode there. And now with the price cuts, it's even more beneficial.
So do you have advice, Aman, for maybe somebody who is using provision capacity mode and would like to know, when or if they should switch to on-demand mode given these new savings?
Yeah,
it's a
great
one.
question. Wow, I wonder how you came up with it. So the way to identify for those customers who are already using on-demand mode, they saw the savings overnight, right, with the price cuts. For those customers who are using provision mode and would like to see if they can benefit from the on-demand price reductions as well, you basically need to analyze your CloudWatch metrics for your provision mode table, and you need to plot a ratio between consumed and provisioned capacities. So you're basically, I'm calling it throughput efficiency, right? If you've provisioned 100 units of write capacity units all the time, and you're using 80 of it, 80 out of 100, your provision efficiency or throughput efficiency is 80%,
Yeah.
right? So similarly, if you're only using 40% of your provision capacity at all times, then you might be better off using on-demand mode instead, because you're over provisioning a lot. So the basic idea is to plot a CloudWatch metric where you compare the provisioned versus consumed ratio, and I like to call it throughput efficiency. You can do it for reads and writes independently. And so the green lines here are for your write provisioned efficiency. The red line is for read provisioned efficiency, and it will be on a scale from 0 to 100, right? So the way to read this is for this particular DynamoDB table, the write provisioned efficiency has always been between 40 and 60%, and sometimes even down to 15%. But on average, it has been in the 30 to 40% range, right? For on the read side, which is the red lines here, the provisioned efficiency has been less than 10%, right? Which means this particular table is massively over provisioned in terms of reads. The usage is less, but the provision capacity is much higher. So there is a threshold that you can you can graph these metrics and look at a threshold and decide whether you can switch to on-demand and benefit from those price cuts or not, right? So if your throughput efficiency, which is the ratio of consumed versus provision capacity, is less than 30% on average, then you can definitely move to on-demand mode, switch your table to on-demand mode, and realize be more cost effective.
And this graph is it coming from the CloudWatch or what?
So this is a metric math graph where you are using natively built supported CloudWatch metrics in consumed versus provision. So consume write capacity units and provision write capacity units, for example.
I see.
And you just make a ratio out of that.
And based on that, you can decide whether it would be efficient to switch to
Exactly.
the okay.
So the
Good.
idea is if you're using less than 30% of your provision capacity at all times, you must definitely switch to on demand and be more cost efficient. If your throughput efficiency is between 30 and 45% on average, right? Not
Mm,
saying that all the time it should be down, but on average, if it's
yeah.
between 30 and 45%, you can still consider switching to on demand. The benefit here would not only be cost wise, but it would also be elimination of operational overhead, right? No capacity planning essentially, because you can just create the table, it will scale as per your traffic and scale back down, and you only pay per your request. So you don't have to uh, for those use cases where it is really difficult to do capacity planning for the future, you don't have to always provision for peak, or you don't always have to think about what your auto scaling settings should be.
Great, thank you. Saying that excellent services. I'm sure the gents here will agree with you, Fawaz. So also uh, another question. Can we mix on demand for new APIs within our apps and provisioned for stable APIs to optimize costs?
Like,
You can't mix capacity modes in a DynamoDB table. So you either have to be on demand for your table and your indexes, or be in provision for your table and your indexes. Now you can change capacity modes, but you're limited to do so it gets a little bit complicated, but basically once every 24 hours you can go back to on demand mode. So the amount of times you can flip and change it. So on an API level, if you're chatting about CRUD operations, then you can't dictate which capacity mode you're going to be in, but you are free to change between them as long as you do it only once every 24 hours. Ultimately, you probably want to be in the best capacity mode for your use. You don't want to sacrifice your application's availability. So if I go back to a man's point where perhaps you're, somewhere just above the line of 30%, you're 40 to 50% efficiency. When you're in provision mode, you still have a tolerance that you could impact your application's availability should you exceed your provision capacity for an extended period. Whereas if you pay maybe just a tiny bit more for on-demand mode, then you are full assured that your application gets the full availability that it should, for a very marginal cost difference if you're that close, or if your efficiency is already kind of pretty poor with provision mode.
And all these modifications, all these changes, it will not impact the service availability, right?
Correct. You can't do anything in DynamoDB, and there's a man mentioned that there's no versions in DynamoDB. You also can't do anything that will impact performance. So you can change your table capacity mode, your table class, or anything else without impacting performance.
Yeah, perfect. Thank you. And Tony is sharing with us here the recommendations on there is capacity reservation recommendations from the AWS console. Thanks, Tony. And
yeah, this was another feature for
oh,
that.
sorry. Yeah.
Basically, now this is all about on-demand capacity mode. But what
Okay.
if you were using provision mode and were happy with it, which is a lot of our customers. Definitely, they're happy with provision mode. They're okay to spend a little bit more on operational overhead.
Mhm.
But at the end of the day, it's different for different customers. So if you're already using provision mode, if you are continuing to use it, um, there's definitely a new announcement for that as well. Earlier, you could benefit from reserve capacity purchase for provision mode tables. So it's like a 1 year or 3 year upfront uh, mode, a plan where you get up to 55 to 77% discount on your throughput costs.
Mm.
Uh, Now, the way to go about this would be, you eyeball your usage. So you see how much you're using throughout the month across all your DynamoDB tables in an account or at an organization level. So that was certainly difficult to do. We had open source a tool as well to make recommendations on how much reservations to purchase. Uh, but again, that tool is open source. It's available. It still works fine. But customers always wanted that seamless ability of integration. So this launch is we have put the reserve capacity recommendations as part of the AWS console itself in the billing console. So now you can go to your AWS billing console and generate recommendations for how much reserve capacity you should purchase based on your past usage of the DynamoDB throughput. So it will give you recommendation on this is how much you purchase based on last 30 days of your usage, and this is how much percentage of savings that would amount to. So there's no tool that you're running. The data is already on the console that you can generate without having to, it's a click button experience essentially without having to run an open source tool.
And I understand that should be beneficial for customers who are running on-demand capacity, right? And
that's for provision mode.
For
So
provision.
for provision capacity, yes, it's super beneficial for those customers running provision capacity.
So the same analysis cannot be done for on-demand capacity?
Yeah, that's correct. So reservations aren't available for on-demand capacity mode tables, or tables which are global tables, or tables which use the standard infrequent access table class.
Yeah, but my question is, if you are currently running on demand and you want to move to capacity mode or capacity reservation, so is it possible to analyze your workloads that's running on demand, and based on that you can reserve capacity and can move to switch to the provisioned one?
Good question.
I think it depends case to case, right?
Yeah, I'm not sure if the capacity tool that recommends how much you should reserve does its metrics based on the provision capacity. And if you're in on-demand mode, you don't have a provision capacity because you're just paying per request.
Yeah.
So I'm not sure if it can do its math correctly if you're in on-demand mode. Typically, it's not. Typically, you wouldn't go from on-demand directly to provision and straight away get reservations, because number one, you want to make sure that workload will work seamlessly in provision capacity mode before taking a commitment for 1 or 3 years. So it's I would, if someone was thinking about moving off on demand to provisioned and then take reservations, I would first move to provision mode and run it there for maybe 1 to 2 months without reservations, and then you can run the analysis of how much reservations you should buy after that.
That's great. And I think that will also bring up another question about how do you do the sizing in the cases like this? How are you going to the amount of or the the provisioned capacity that you're going to provision for your table? What's what the needed data that you need to have in order to provision correctly, not accurately, of course, but at least you are not being impacted or you are not hurting the performance of your application.
Yeah, for me, my recommendation is if you're coming to DynamoDB from another database, or it's a brand new application, that you should probably always just use on-demand first. On-demand will give you its pay per request, so you don't have to worry about provisioning. And then after maybe 2 weeks or 1 month in on-demand mode, you can start to analyze your CloudWatch metrics to understand, what your kind of troughs and peaks are, and then you can decide to go to provision capacity. You'll have a baseline of what your table is actually, or how it's behaving in terms of consume capacity.
Yeah, makes sense. Yeah, for all of our viewers, we are currently discussing the Evolving with DynamoDB's new announcements. Seeing 7 messages in the chat from our viewers. Hello, guys. Pranay, and we have Priya, we have James saying hi, greetings to all. James O. Reading, Reading, UK. Great data analytics and science being shared on the screen presentation. Thanks a lot, James. And then we have a question. If we have multiple DynamoDB tables, will the metric math dashboard show read write for each table or consolidate them?
Yeah, so this will have to be done on a per table level at this point. It's basically metric math between consumed and provision metrics for each table, because the consumed and provision metrics for each table are independent, they're distinct. So you need to do the metric math on a per table level. You can also do it for a GSI or a global secondary index. Uh, but it has to be done on a per table level, because maybe some tables have completely different workload, different traffic patterns, and others may have different traffic patterns. So it's not really, it may not really make a lot of uh, sense of consolidating it across several tables together. But I'm sure you can still do it using metric math. If you have 5 tables that have the same traffic patterns, you can just add them together and plot this throughput efficiency.
Nice. We also have a question about any recommendation how to optimize provisioned capacity mode. I think we mentioned a couple of things throughout the session, right, guys?
Yeah. So yeah, reservations is one for sure. But then other things you can look at is the efficiency of your data model. So in DynamoDB, your data model would directly impact how much you spend in your provision capacity. That can be things like maybe splitting large item into multiple smaller ones, and there's loads of other types of uh, data optimizations you can make, which is available in our documentation. If we can get a link to that, we'll share it. So yeah, to optimize provision capacity, reservations, and the second thing then is your actual data model and how you access the data.
Okay, that's perfect. Thank you. Okay, so let's move to another topic, and I know Aman is so interested in that one, which is the zero RPO. Aman, the floor is yours.
Lee, you want to take this on?
Yeah. So
Okay.
yeah, global tables is not anything new to DynamoDB. DynamoDB, in my opinion at least, is probably one of the better things that have global replication, in the fact that their replicas are also active. So it's active replication. So you get multi-active, multi-regions. It provides you 5 nines SLA and availability. So DynamoDB's global tables gives you 5 nines SLA, where SLA is a service level agreement, so we guarantee you 5 nines. A standard DynamoDB table gives you 4 nines. You add at least one replica, you get up to 5 nines. You store the data where it's used, so it gives you ultra low latency to your users wherever they are based in the world, full global replication. And it's also really, really good for disaster recovery scenarios. And that's where the new version of DynamoDB Global Tables comes in, and it's called Global Tables Multi-Region Strong Consistency. It's currently in public preview in the US regions. And basically what it is, it's a globally distributed application that needs a recovery point objective of 0. So it does 2 things, and we can break this down a little bit. So first of all, a recovery point objective. What a recovery point objective is, if something were to go wrong, if you were to redirect to another region, so let's imagine we had a full region failure, touch wood that never happens, but let's imagine we had a full region outage and you transferred then over to your other replica, your application stack to your other replica. How much data can you afford to lose? Or in-flight data, for example. And with the standard DynamoDB global tables, so multi-region eventual consistency, you are sort of in low digit seconds. So you could lose 1 to 2 seconds worth of replicated data. Whereas multi-region strong consistency is guaranteeing you an RPO of 0, meaning that there will be no data loss in the event of an outage. So let's imagine you were writing to one region and that region went down. Any of the regions that accepted that write will be guaranteed to exist in the failover region, which could be, whatever region you're failing over to. So zero data loss, and that's where the term zero RPO comes from. That's one of the key points of multi-region strong consistent global tables, but it also piggybacks and provides you an additional feature, which is strong read consistency no matter which replica you're in. So if I write to US East 1 and I do a strongly consistent read in US West 2, I can guarantee that I'll get the most up-to-date data. So if you want to push through the slides a little bit, man, and I would just show real quickly what that looks like and how it compares to the eventual consistency global tables. So this is a standalone table. You make an update item, and then you do a strongly consistent read. So if you do a get item without strong consistency, you may get stale data. So I've written to my table, and straight away I do a get item. It's eventual consistent by default. I may get stale data. That's how DynamoDB works. Now, if I do a strong consistent read, if I do an update item and I do a get item with strong consistency, I am guaranteed to get the most recent state of that data. That's a guarantee. So whatever you've written, you're guaranteed to get it back if you do a strongly consistent read. Then we'll move over to global tables, and this is where things change a little bit. So if I do an update item to US West 2, for example, and then I do a get item from US West 2. If I do it strongly consistent, I am guaranteed that the item I wrote in US West 2 will come back to me in US West 2. But if it was written from US East 1 and I do a strongly consistent read in US West 2, I am not guaranteed the latest version of that data because it is not yet replicated across from the other region. So here we have DynamoDB global tables, which is the global tables that everybody are familiar with currently. And each one of the replicas act as a standalone DynamoDB table. If I write to that region and do a strongly consistent read in that region, I will get back fresh data. If I write to that region, but another application reads in a different region, I may get stale data. Now that brings in multi-region strong consistency, and this is where things change a little bit. So if I do an update item in US West 2 and I do a get item in the same region, I am guaranteed strongly consistent data. I will get the freshest data there. But likewise, if I do a strongly consistent get item in the other region, which is US East 1, I am still guaranteed strongly consistent data. So not only does it give you a zero RPO, meaning that if you have to fail over, you're guaranteed you'll have the latest set of data in the fallover region. You're also guaranteed to get strongly consistent reads and get the latest version of that item, no matter what region you're reading from. So if I break that down a little bit and we compare multi-region eventual consistency, which are the global tables that you're familiar with, against multi-region strong consistency, which is the tables that are currently in public preview in the US regions, eventual consistency gives you lower write and strongly consistent read latencies, where multi-region strong consistency, you have higher write latencies, but also higher strongly consistent read latencies, because you have to wait for all of the writes to sync to all replicas before your read will be performed. So slightly higher. The latency depends entirely on how far apart the replicas are. Closer together the replicas, the lower the latency. The further apart they are, obviously the higher it goes up. We can't define physics. That's just the way it is, unfortunately. With eventual consistent global tables, strongly consistent read can return stale data because you would have another replica that may have written that. Whereas in multi-region strong consistency tables, a strongly consistent read will always give you the latest version, no matter where it was written. Eventual consistency, when conflicts happen, so two people write to two people write to the same item, but in different replicas or different parts of the world, you get a conflict. And with the standard or the global tables we're familiar with, conflicts are resolved by last writer wins. So DynamoDB tables inject a timestamp into modifications. Whichever one has the greater timestamp will be the one that wins. So all replicas will synchronize to have that item as the final image. Whereas if that happens in a multi-region strong consistent global tables, the first one will get accepted and the second right with the lower time or the higher timestamp will get rejected because it'll conflict with the one that's already ongoing. As I mentioned earlier, a typical recovery point objective in the eventual consistent global table is single-digit seconds. So there is, if you fail over, you may lose a couple of seconds worth of data because it was still in flight, where RPO 0 is guaranteeing a recovery point objective of 0 with the new strongly consistent global tables.
That's amazing. And I believe we have a demo for that as well, right?
Yeah.
But before going to the demo, we have a couple of questions. So Jayesh Hamash saying, with the latest DynamoDB updates, how do these enhancements impact stability and cost optimization for larger scale application? Are there any specific improvements in query performance or I believe with the multi-region application, we just covered this right now. But what about the query performance?
Do you want to go ahead, Aman?
Yeah. So for these features have no worse impact on performance. You're still dealing with the DynamoDB table at the end of the day. That's gonna guarantee you uptime. Has an SLA with it. Scalability is still the same as it used to be. Right? There's price reductions and there's reservations that can help you with cost optimization. To start off with, there's a number of things you can do in the cost optimization space. I'm sure there's an endless number of things that you can look at, but you also got to think about at one point the cost of investigation becomes more than the cost of savings. But then there's definitely multi-region replication if you like zero RPO. If you're in the financial services or like healthcare industries, if those kind of use cases where you cannot really accept data loss. In those cases, I think the zero RPO multi-region global tables really would help you. In terms of read performance, it'll still be the milliseconds, single digit millisecond that you get on average with DynamoDB in any deployment format. And for writes, we'll actually see that in the demo. So I'll be happy to show that.
Sure. Just one last question. I'm sorry, go ahead, Lee.
Oh, I was just going to say, they asked about, does any of these features have, or any of the announcements had any cost implication on globally replicated or global applications? And yes, the price cuts to DynamoDB global tables has a huge impact for any large scale globally distributed app. Yeah, as well as I think we focused more so on the on-demand price cuts, but it's also important to be aware that global tables also has price cuts for writes.
Okay, great. Sergey is asking for the GSI. I believe there's the global secondary indexes, right? On the DynamoDB table, if I set on-demand capacity, the price would reduce the same.
The important thing here is, the short answer is yes, but the important thing is the price will only, you will be more cost efficient if and only if your utilization or throughput efficiency for the provision mode table is under 30 to 45 or under 30%, right? If you're already super efficient on your provision mode table, then maybe switching to on demand may not make sense cost wise. But if you're talking about over provision tables, which generally happen to be the case when you're not sure of your peak loads, or you're not, you definitely are not doing capacity planning on a regular basis. In that case, what customers do is they always have some buffer even above their expected baselines, so they're already a bit over provisioned. In many cases, that over provisioning is not a bit, it's quite more than that. So for those use cases where the throughput efficiency, the ratio between the consumed capacity and the provision capacity is under 30%, In those cases, both the table and all their GSIs will benefit from switching to on-demand. So when you can't have a different capacity mode for your table, but have different for the GSI. So it's one capacity mode for everyone. Now, definitely that's where you decide if it's under 30%, definite switch. If it's between 30 and 45%, then you might need to consider the total cost of ownership. And if it really makes sense for you to make the switch, because you are definitely gonna be more efficient on the operational overhead, right? You don't have to do capacity planning. You don't have to adjust your auto scaling configurations all the time. But if you're more than 45% utilized in your throughput efficiency, by all means, stick in on demand. That is going to be good for you.
Makes sense. Okay, so it's demo time, and
Yeah.
Man, I believe we are going to show our viewers
Sure.
the RPO of the global tables, the RPO of 0 for the global tables.
So what I'm doing here is go to a DynamoDB console. I create a new table. I call this demo. I'll provide a partition key as PK, provide a sort key as SK. I hope everyone can see it. I'll have default table settings. So by default, the table will be in on-demand capacity mode. The table class will be standard. I can always edit these configurations after I've created the table. And now I'll go ahead and create the table. So at this point, my demo table is a single region DynamoDB table, right? A normal table in a single region, which is Northern Virginia. So it's US East 1.
Okay.
So I'll hit refresh, and by now the table is already ready. I go ahead to the table and I will make it global, right? And I will add replicas to it in different regions. So whatever I write to the US East table, it will be replicated automatically to other regions. Now, when I add a replica, this is the new feature where it will ask me what is my consistency for reads, right? Am I interested in eventual consistent reads, or would I want DynamoDB global tables to support strong consistency, which is RPO 0? So while creating the replica, I can hit strong consistency. Of course, it's a preview feature right now, so it's just giving me the little warning. But it is important to note that when you create 0 RPO global table replicas, you must have a total of 3 replicas. So you must be deployed in 3 regions.
Okay.
That is the minimum. So for now, I had the table in US East 1 already, but I will also add replicas in US East 2 as well as US West 2. So 2 more regions in addition to what I have.
And the replication is happening simultaneously at the same time?
Yes.
Okay.
So that's the 0 RPO because I've selected strong consistency. Whenever I write to one region, it is guaranteed to be available in the other region when I read it immediately after.
Okay, so it will not acknowledge you unless it's already written to the other 2 regions.
Correct. So that's the replicas created, and maybe it should take a few more seconds. You can see I have 3 replicas now, with 2 of them in creating mode, which are in the different region. Right. I would wait for it to be created, but I already have the table created that runs my script, so we can talk about the script until then. Now, I have a script that basically just does a bunch of things. First of all, it goes to the DynamoDB endpoints. The overall, it's built to measure read and write latency. So after I write an item to the US East 1 replica, I want to immediately read the same item in the other regions and see how much time it took for me to read them. Right? So from the same region, I'm making my request from US East 1. So obviously the other replica, the network time, turnaround time, the round trip time is going to be really high, right? When I say really high in DynamoDB terms, that is 50 or 60 milliseconds,
Okay.
right? But the write time as well as the read time is also something that we'll monitor. So we'll log that in our script. So we'll make a write to one region, immediately make a read for the same data in another region, and see if, first of all, we see the item already, right? Because 0 RPO, we should be able to see that in the first attempt itself. We'll
Yeah.
keep trying to read it from the other region, and then we will, once we have read the item the first time, we will also log how much time it took for us to go and make the read. So we get an idea of what sort of read replication latency we're dealing with.
Yeah.
Right. So two things we are testing. One is the 0 RPO functionality, where we make a write and immediately the first attempt we make on a read in another region, we are able to see the data. And the second thing is how quickly we are able to see that data after making a write. So the replication latency.
Perfect.
For the purpose of the demonstration, I'm also sort of logging the round trip time to the other region. So because I'll be using US East 1 and US West 2, the further apart replicas from this group, we'll also measure how much time it takes just to make a TCP ping into the DynamoDB endpoint. So what we do in our script is first make a TCP ping to both the DynamoDB endpoints and measure what is the average round trip time.
Okay. Okay.
Right, so that we can ignore that round trip time from the overall latency. So the table I have here is MRSC table, which is short form for multi-region strong consistency. We also call it 0 RPO, if you haven't noticed. And I'll use a Cloud Shell. I definitely want to. Yeah. So my script there is here. I need to pass it a write region parameter. So my write region will be US East 1, which is the same region that I created the first table in. And I will immediately read it from the other region. The read region will be US West 2, right? And we will let it run for a bit, but then we'll just stop it at the end and look at metrics and stuff.
Okay.
Because it will appear to be like a fast train, and it's gonna be a little difficult to go through the logs there. So what it does is it will measure TCP latency to both the endpoints first, and then it keeps making a write to one table, one region, and then keeps reading it the same exact item from the other region, and then monitor the latencies for writes and reads. So this can just keep go on, but now I can stop it so that we can read what it's saying. So it writes one item here with a particular partition key and a particular sort key, which is the actual timestamp of the write. And then it measures how much time it took for the write to complete. So as soon as we get an acknowledgement HTTP 200 from DynamoDB, we consider the write to be successful in the application. So this is the end-to-end time, essentially. My Cloud Shell making a request, the request hitting DynamoDB, the write being confirmed, right, onto that multi-region infrastructure. And then once I get back the acknowledgement, I stop the timer.
I see.
So this is about 27 milliseconds. It ranges from 25 to 37 milliseconds in this area. And my average round trip time is about 1.5 millisecond, or 1.3 millisecond here.
So 27 milliseconds to write to both regions or three regions at the same time, right?
Yes. So once I make the write already, the way it's designed, DynamoDB makes a write to a multi-region log, multi-region setup, which powers the 0 RPO feature.
Okay.
So it essentially does not have to go through
So it's like
completely to the other way.
a global resource, and then it
Yes.
will be used. Okay.
So
Okay,
it's
makes
it's
sense.
sort of a multi-region log, you can say, that is
I
highly
see.
available, highly scalable, all of those things.
So you,
But it only needs to write to the closer region. Go
yeah.
ahead.
So if we're talking about eventually consistent global tables, which is the ones that everybody's familiar with today,
Yeah.
writes are usually in single-digit milliseconds. When we move to multi-region strong consistency tables, if you need zero RPO or strongly consistent reads across regions, you do pay a little bit more latency. Here we're looking at 100, what was it, man? 27
20.
milliseconds. So it's about 20 milliseconds more than what it would have been in the eventual consistent table. The same applies for strongly consistent reads. With the eventually consistent DynamoDB table, you're chatting single digit millisecond, where because of the way that globally replicated log works, strongly consistent reads will also pay a little bit higher latency penalty.
Because in eventual consistency, then you're not waiting for all the regions to acknowledge the writing. It just once it's written in that
Exactly.
global log, then it's okay. Then you return, and that's it.
Yeah.
Okay, yeah, makes
Yeah.
sense.
And it's important to call out that you can do eventually consistent reads against the multi-region strong consistency global table, and those will act as normal. But
Okay,
it's when you specify you want strong consistency in your read, then you could have an increased latency because of the global replication needs to be strongly consistent.
and it all depends on the use case itself. If there's real need for something like that, and you can accept high latency, then you can go for this solution.
Yeah, I
And
mean, if you have like sort of a social media application, you can probably, and you're counting, or a music playing application, and you're counting the number of downloads that happen
yeah,
of, or the number of comments that you see on a post. I think it's absolutely within acceptable range to
exactly.
have some kind of delay, of a few
Yeah,
seconds, let's say.
yeah,
Whereas with healthcare based systems, with healthcare based
financial.
or
Yeah,
financial services, if once the data is written, you want it available in the other region right away, right?
perfect. Okay, so we only have like 3 minutes left, or 2 minutes actually. So, and one last topic that we have, which is I think we wanted to talk about the warm up of the pre-warming, I believe, right? The pre-warming of tables and indexes.
Should we do pre-warming or just do the brief run of 0 ETL?
Okay, okay,
Yeah, let's do zero ETL really quick.
okay.
Yeah, I think it's more engaging. So I'll start by giving maybe a quick overview of what zero ETL is. So ETL stands for extract, transform, and load, which a lot of people that are used with manipulating data will be aware of. Usually it involves setting up pipelines, which can vary in complexity. And what AWS has kind of gone through over the last 1 to 2 years is creating something called zero ETL, which basically means zero effort on your behalf, that AWS will fully manage the ETL pipelines for you. And with DynamoDB, that gives us kind of 3 destinations for zero ETL: OpenSearch, SageMaker Lakehouse, and Amazon Redshift. So maybe you want to give us a little bit more about each of these integrations, Aman?
Yeah. So I think maybe in late 2023 or early 24, we launched the zero ETL integration to OpenSearch. And the basic premise behind that was like, DynamoDB we know is super scalable, is highly performant. Uh, it is able to do that. It is able to give those design tenets, at any scale essentially. And the reason behind that is because of its design, because of how it is built. It does not allow you to do unbounded work. It does not allow you to be, having like, it's not great when you have like 20 optional filters in your query patterns, right? So I might have 20 columns or 20 fields, and in my queries, all of those 20 fields have a filter, but all those filters are optional. Those use cases are not great for DynamoDB, not well suited for OLTP at scale.
Yeah.
And so the pattern to address those kind of access patterns is using a search-based system for a search-based problem. And that's why OpenSearch comes into the picture, where majority of the access patterns can still be handled in an OLTP fashion in DynamoDB. But then for these high level of unknowns, uh, rich query flexibility, we like to call it, you need a search system like OpenSearch with it. So to keep those two in sync, you use DynamoDB streams and Lambda function. That's one. So before 0ATL came out, we use that kind of system with streaming, with Lambdas, and there was some kind of plumbing involved. With 0ATL, that goes out of the way.
Nice. And similarly, we have the same thing for the Redshift and SageMaker Lakehouse.
Exactly. I think SageMaker Lakehouse is particularly interesting without diving too much into it. It's basically Apache Iceberg tables on Amazon S3. And that is super powerful. You basically have your copy of DynamoDB table in S3 available for rich analytics, for complex analytics. Run Athena, run your glue jobs, ingest into your data lake, integrate your data, DynamoDB data with data lake, and you don't have to write code for it. I think there's super value in that.
Perfect. Okay, one last thing. One of our viewers is asking, can you please share the Python code that you wrote for this loop test?
Yeah, I'll put that on the LinkedIn post when we add this the stream
Perfect.
recording.
Perfect. Thank you so much, Lee, Aman. Thanks again, guys. Thank you so much for joining us today. And I believe that was a very informative session. We covered different topics about the new announcements of DynamoDB tables. For all of our viewers, you can see the recording of the session. It will be available on our community page. And also for the next week, please tune in, and we will have a session next week about the Amazon S3 tables, and we'll be covering it's a new announcement as well. So tune in next week, 4 p.m. CET, 8 a.m. PT. We'll be waiting for you. Thanks again. Thank you so much for your time.
Thank you.
See you next week. Bye-bye.